All right, so I just want to run through a couple of other pieces of information you can be given that will let you solve for G, F, and C and form the equation of a circle. I won't go through full examples with these two, but they do come up from time to time, and they're useful to know. But just to summarize real quick, if you're given points on a circle, you can sub them in for x and y to the G, F, and C equation, and they will give you equations with G, F, and C in them. And if that's all you're given, you should get 3 of them and be able to use simultaneous equations to solve. If you're given a line that the center is on, the center is minus G minus F, so you can sub minus G minus F in for x and y, and that will give you an equation with G and F in it. If you're given the radius, well then from here, the radius is equal to the square root of G squared plus F squared minus C, so that's giving you another piece of information with G, F, and C in it. That will lead you towards having 2 possible equations of the circle because of the G squared and the F squared leading to a quadratic. Another thing they can tell you is that either the y-axis is a tangent or the x-axis is a tangent to the circle. And I'll just run through what that tells us about in both cases. So if the y-axis is a tangent like I've got here, I've kind of marked in the actual numbers on this. So I can see that the center of this circle is 3, 5. Okay, so the center there is 3, 5. Okay. A radius and a tangent always meet at a 90-degree angle. They're always perpendicular, okay? So that's an important thing that comes up a good bit, okay? So this radius here that I've drawn out to the point of intersection between the circle and the tangent will be perpendicular to the tangent, and the tangent is the y-axis. Because this and this are perpendicular, then I know for sure that this point of intersection between them must be 0, 5. Okay, so that radius and the y-axis are perpendicular, so that means that's a horizontal line because the y-axis is vertical. So reading across this must be 0, 5 where they intersect. Okay. Now, instead of looking at them at numbers and looking at it a bit more kind of abstractly, when I'm dealing with the G, F, and C equation, my center is minus G minus F. Okay, so that means this point over here must be 0 minus F. So whatever minus F is, that's how far up this point is. So this point over here is 0 minus F. Okay, so if the y-axis is a tangent, then 0 minus F is on the circle. Must be a point on the circle. All right. That would be enough for you to kind of remember, and you can use that and sub it in. But it does kind of give us just an easier kind of succinct point that I'll get to in a second. But 0 minus F is on the circle. It's the point of intersection between the tangent and the circle. So subbing 0 minus F in then, so it's on the circle, which means I can sub it in for x and y. So x squared is going to be 0 squared plus y squared is going to be minus f squared plus 2g times x then is 0 plus 2f, y then is minus f plus c equals 0. So 0 squared is 0. Minus f squared is just f squared. 2g times 0 is 0. 2f times minus 2f is minus 2f squared plus c equals 0. So on the left-hand side here, I've got f squared minus 2f squared. That's minus f squared. If I bring that over to the right-hand side, then I get c is equal to f squared. right? And that's the kind of result of this. So when the y-axis is a tangent, c is equal to f squared, okay? So if they tell us in a question the y-axis is a tangent, that can be my third piece of information for forming the g, f, and c. All right, and that's why it happens. Okay, that's just kind of taking it through step by step. And if you remember that, great. If you need to maybe do this little bit of work and kind of think it through a little bit and go, yeah, okay, 0 minus f is on the circle, that gives me this. Fine, that'll only take you a minute or two. All right. We have a similar result then with the x-axis. So kind of similar thing. So looking at this circle here, the center is 4, 3. This point down here then, because the tangent here and the radius are perpendicular, and because the x-axis is horizontal, this must be vertical. So this is directly down here. So this must be 4, 0. This point here is 4, 0. But equally, just like I did over here, I can also write the center as minus g minus f, which means this point down here I could write as minus g, 0. So when the x-axis is a tangent like this, then minus g, 0 is on the circle, okay? That means that I can do a similar kind of thing that I did here. So sub this in for x and y because it's on the circle. So x squared now becomes minus g squared plus y squared becomes 0 squared plus 2g. X now is minus g plus 2f, y is 0, plus c equals 0. So let's just multiply this out. Minus g squared is g squared. That's 0. 2g by minus g is minus 2g squared. 2f times 0 is just 0 plus c equals 0. So g squared minus 2g squared is minus 1g squared. If you bring that over to the other side, then it's just g squared. All right, so it's up to you, I would say, if you want to kind of learn off when the y-axis is a tangent, that means c is equal to x squared. When the x-axis is a tangent, that means c is equal to g squared. But I think you're better off being able to kind of think it through a little bit and kind of, okay, when the y-axis is a tangent, that's what's going on. 0 minus f must be on there, and I can get it that way. When the x-axis is a tangent, that means minus g0 is that point. I can sub it in and get my result there, okay? But again, just y-axis is a tangent, x-axis is a tangent. That can be the third piece of information they give you, and that's what you get from it.